So the next example is, so the graph is g of x equals -1/2 x plus 5 times x minus 1 squared times x plus 2. And in this case, basically what we're going to do is identify the x-intercepts. So hopefully you remember that the x-intercepts is going to be when g of x is equal to 0. So I can set -1/2 times x plus 5. And again, also I mentioned, if you guys do have a question, if you guys saw what I'm missing up in this problem, like where my mistake or whatever else I was, like my confusion, please feel free to let me know in the chat, because I want to look back into there. But I was trying to see what was not making sense from that problem. And I know I want to look at the graph and kind of recognize this, why that is not working. So, but I do want to make sure I can provide you a better explanation. And if I'm not able to get to it, which probably tonight, because typically I want to make sure I can think through the problem and not be on the cuff when doing a live stream, which is not ideal, then I'll just make sure that I respond to you in the community post. All right. So in this next one, we have 0, -1/2 times x plus 5. Then x minus 2 or x minus 1, sorry. Quantity squared times x plus 2. All right. So basically, now what we can do is go ahead and apply the zero product property. Now, one of the main issues is, we have all these products equal to 0. But one of the main issues here is we have the scalar. Now, again, the first thing we could do is we could multiply by a -2 on both sides, and that would get rid of the scalar. So again, remember the scalar is not going to be an x-intercept. The only thing that each of these factors are going to produce our x-intercept. So I'm going to have an x plus 5 equals 0, x minus 1, quantity squared equals 0, and x plus 2 equals 0. All right, so therefore we have x equals -5. Here you take the square root of both sides, and you can see x is equal to 1. And then here x equals -1. I'm sorry, -2. Okay, so now let's just go ahead and plot those points. So I have a -1, 2, 3, 4, 5, -2, and a +1. All right, so those are going to be the zeros. The next thing we need to do is, if you were to multiply this out, what would be the leading coefficient and the degree? So if I have -1/2, right? If I was to expand an x minus 1 squared, that would give me a x squared, right? That would be the highest power. I don't know what the rest of the well, I do, but let's pretend I don't know what the rest of the expansion would be. I know that the highest power, when I multiply x minus 1 times x minus 1, that's going to give me x squared. So this is going to produce an x squared. ... Well, if I multiply an x squared times another x, that'd be x cubed. Multiply by another x, that'd be x to the 4th. So I don't know what everything is going to be, but I know it's going to be an x to the 4th something, right? If you were to multiply this out, the highest power that you would get for your variable x would be to the 4th power. Now, I recognize that's an even power, but since my leading coefficient is negative, the leading coefficient test for the end behavior tells me my graph is going to go down and down. All right, it's going to fall left, right. The other thing we want to do is look at the multiplicity. Now, again, the multiplicity is going to be the power of each of our zeros. When our multiplicity is odd, that tells us that the graph is going to cross at an x-intercept. And if our multiplicity is even, that tells us the graph is going to bounce. So at -5, you can see that's an odd multiplicity, so the graph crosses. At 1, the graph has a even multiplicity, so it's going to bounce. And then at -2, it is odd. So if I was going to kind of follow through here, well, that has to cross, that has to cross. And now you can see that it's going to bounce and then go back down. So the graph is going to look something like that. 4a minus 5 must be greater than or equal to 0. Yes, that is true.